installation. So whatever we have refreshed the repositories along, each of those are now going to be installed when you call these installation commands.
So the package which we are installing is what we need for our build, development, running of the system. So these are the essential packages which is not there into base SUSE installation. That's why we are installing it separately. Zipper is a utility to install the package on SUSE. In Linux RHEL, same utility is called yum. In Ubuntu, it is called apt. So depending on which environment you are running, you will always run on SUSE.
A couple of things take more time. This is the first one which takes time, and also the Gradle install takes time. Other than that, most of them finish pretty quickly.
What's the total space you have given for
60 GB. 6 GB RAM and 60 GB.
64, I think. 4 is enough.
Should be. I mean, the recommended here is at least 60 GB in the root system and 6 GB. So went with the recommendation for the install.
You can go for the thin provisioning.
Yeah.
Which basically makes sure that if you are not using full 60 GB, it is not allocated. So that is the way to provision your
If we have 6 GB, then we can get 4 GB. If we have 4, we can get 2. Like that.
Yeah.
These people are having laptops with 8 GB, 4 GB, 8 GB, 4 GB.
Laptops with hard drive capacity.
No, RAM.
RAM. Okay.
So I think 2 of them just bought recently 8 GB with 8 GB.
Okay.
5. So is it okay them working in the college? They can have their own installation.
They can.
That's better, I think. And they
It's better. Only thing is you have to figure out how to do that. Because what we have standardized is through VMware, and now when you want to do it through their laptop, you need to create that virtualization layer and then
sharing is required among 3. One has created.
one.
No, one has created.
Okay.
Sharing is required.
Okay. Need to figure that out probably.
Because individually you won't recommend.
Yeah.
At one place it has to be and you access through that. That's what
Individually they can do it. We don't have a restriction as such. So you're saying basically one will do the CoprHD install, build and deploy, and they will share it.
no, they can even have individual. But again, collaborative, like one place virtual is there.
Mm.
That will be better.
Yeah.
Somebody like he has a good laptop, good 16 GB. And you can give the IP.
Correct.
That will be better.
Yeah, that's the one. You have packages that we downloaded. So we have downloaded, configured, and installed. Then now we choose the Java version that we will be using. Recommended is 7, so we just choose that. And now comes the actual part of checking out the code and compiling it. So the code is located. So before we do that, we need to give the network IP for CoprHD again as part of the. So we gave the IP address during the installation. So this is a single node installation. So we will be using only one of these IPs. We will be repeating it even for the actual IP and the virtual IP.
So we talked about that we run it into the load balancer mode. So this is the configuration for the load balancer. Right now we are running into single node, so only one will be.
So with that, this is done. So we check out the code. We can go back to the home directory. You can create your own directory or whatever, and then.
So up to this point was the configuration of your, SUSE thing. We have made it a cluster with a single node. Now we are starting downloading our CoprHD code, which we will be putting it on this appliance. So this has become an appliance now. You know what is an appliance? It's a software appliance. Appliances where you have your OS and application bundled together. So CoprHD is deployed as an appliance.
This is the JIT configuration which we use for versioning the code.
This is an important step. Please don't miss it. You need, when you are contributing to CoprHD, you have to give the proper name and the email address so that you can get the notifications.
How many of you are registered already? CoprHD? The link was sent. Registered. Okay. So what does it mean? What kind of accounts they have? No, they have registered it. You need to create a Jira and get them a contribution access. So you are registered as a just. We'll take care of it.
So this is the actual build command.
Just go slow.
Okay.
Explain what you are doing. So now he is actually building that code. Make clobber RPM. So once it runs, it will compile all the source code depending on download certain environments, like we are downloading certain packages also. End of the day, once everything goes fine, you will get in 1 RPM.
So once the build is successful, you will see the RPM location being printed. So once it prints that, you can use that and deploy the RPM, install the RPM. So probably after this we can break for lunch, and once we come back we will deploy the RPM and continue. We installed the SUSE Linux OS, and then after that we configured all these RPM repositories. Then we followed it with installation of all these 7 RPMs that we had downloaded. Then we installed the ng-inx server, nginx. So this, after this process, we checked out the code, and we gave the build command before you all went for lunch. So the build is done. So the build is successful. It took around 11 minutes. This is the time it has taken to finish the build. Then after the build is done, we need to deploy the, it will print the location of the RPM file that is generated. So this is the storage OS RPM file that is generated after the build command, and this is the location where you find this. So we use this and then we deploy the RPM. So I have gone ahead and done that also, RPM minus UVH, then we have given the RPM location. So once this is done, we are done and ready to launch the UI, ready to access Viper. We can use Viper also, right, or CoprHD only. So you normally now you will see it as Viper in the UI. So before we go there, we will just see if all the services are started. So this command etc storage OS status, this prints out all the services if they have all started. So Manoj in his presentation gave you all the details about what are these services and what they do. So this command, the status command, shows you everything that is active and running. So this is the first verification that you have to do. Everything should be active and running. If something is not running, you have an option of restarting just that, or you can restart the whole thing. So make sure that all these are up and running. Second thing you need to check is the ng-inx server. So this is also running. So if these two are running, then very likely or 100% you can be sure that the UI will launch. So if these two are have anything in red, anything inactive, or anything is not running, or it shows an error message here, then we will need to debug further. So even that is updated in the wiki. We have a whole wiki page dedicated to what are the things that can go wrong and how you can debug further. So now I will access this through the UI. You want to say anything about this?
No, actually, services get binding to the ng export, so it takes little time. First time when you start the system, so it will not immediately come that much.
So password is root change me. If you had given a different
password was root password.
Root change me. So if you had given a password during your SUSE Linux installation, that will not work here. So once you deploy this, the default password itself changes to root and change me. That is also mentioned in the wiki. So that is one thing you may need to remember. Towards the end of the wiki, that is when you monitor the startup, below this we normally, when prompted for user credential, login with root and change me is clearly mentioned. So don't forget this and try to use your password which you gave during your installation. So once you do the initial login, you will be asked to change the password, give an administrator password. So that's the first step, and after that we will proceed with discovering the storage and other things.
It shows EMC Viper.
Yeah, it will show EMC.
So we just created the open source avatar of Viper that we call CoprHD a few months back. We are in the process of segregating some of the branding and look and feel, but consider it a work in progress. After some time, I think probably the commercial version will show EMC Viper, whereas the open source version will say Copra.
So So again, the same configuration you have to apply over here. DNS what you gave during your RP unit.
Okay, so you can see the version 2.4 open source. Then these are all the different options that you have. This is to discover the various aspects of your network. You can discover your storage systems, your fabric managers, configure your networks, discover your hosts, clusters, and all that. Then you create virtual arrays and virtual pools. So this is the EMC Viper abstraction layer, where you pool together, the various arrays that you would have discovered. Then you have a service catalog. So when Manoj was talking about orchestration, so this gives the interface to all the various operations that you can orchestrate, on storage, provisioning storage, the creating volumes, and then exporting it to a host or a cluster, so on and so forth. So this gives you a list of all the storage that you create, volumes, snapshots, and so on and so forth. And probably we will keep our understanding to this level for now. So before we start discovering this, we also have a simulator which simulates these storage devices. So we have different storage devices: block storage, file storage. You have Vmax, VNX, Extreme IO, and so on and so forth. So instead of using what happened? Oops. Okay, instead of using the real storage, probably you also may not have access to them either. So we simulate those, and so that procedure is what I will show next. We just simulate that storage. So based on that simulator, we will be doing the discovery and the provisioning.
So these simulators are very much the emulation of our hardware. So whatever you can do with the real storage, this simulator will be able to achieve all of it. We know that all the institute will not have the access to any storage arrays, so that's why we have specifically created simulators for you, which is available also on the CoprHD website to download, deploy in your environment.
So this is the all-in-one simulator, the AIO simulator we call it. So I am taking the OVF file, already downloaded this onto my desktop. So in the vSphere client, I have started deploy OVF template, select the OVF, and again you need to provide the network details similar to what we provided for the CoprHD deployment.
So this is a very crucial step, and we recommend sharing simulators rather
Correct.
than each one of you setting up your own VM for simulators. Think of it like a shared infrastructure or shared lab resource.
So you will need all individual IPs for your CoprHD setup, and you can share one for the simulator.
Yes, I'm sorry. Yes, absolutely. Yeah. So while he's doing it, we have Vice President ASD Division who happens to be here this week, Eve Scott Ludwig. And when we told her about this initiative and all of you being here, she's got very excited and she wants to meet you. So she will be here for about 10-15 minutes. So we will take a small pause in this activity and hear her thoughts.
Still, for some reason it's too slow. What we are doing is we are going to, this is a simulation or okay, there's another one, the NetApp that's already simulated. So we are just going to discover that using the IP address and the credentials. So in an internal wiki we have given these details which we are just reusing for this particular simulator. So similarly, even the simulator that you deploy will also have, basically it's a it has all the OVFs which has multiple simulators. So with different ports, you can discover different types of arrays. So this is the NetApp array. I'll just give a name. This is the name that you give. So port 443 is good enough for NetApp, right? Okay. So I'll click on save, and this is the first part where you discover the storage. So once you discover the storage, you can create a virtual pool. Status is
Oh, is this 2 for right?
it's a different setup. Okay.
So
You can just check if it's pinging. Just wait for a while till it's reachable. Minus T.
Check the console of that. No?
Um,
Check the console of that.
yeah, it's pinging. So once that is available, you can rediscover. Okay, this is not on this network, so I'll first discover the Vmax array, and the password for this also is mentioned in the wiki. Root change me, right? Yeah.
Password is case sensitive, so
Yeah. So you can see the status here. So once it is successfully discovered, you should see it all in green. So that will give us the go ahead to discover other things.
So as we talked in the morning that first you have to take the physical system and bring that into our virtual world. So we are first getting all the resources from the physical world, and then we will show that how to make a virtual world of that. This is a different type of arrays from EMC called Extreme IO.
So you can see all the Vmax arrays and the extreme IO is all discovered. Everything's the status is in green. That means they are all reachable, accessible, and accurately discovered. So next we will just check the.
Click on ports and ports and show like what is.
Oh, here. Okay.
Yeah.